Okay, so now I'm working on album sales, and this is the example from Darren George and Paul Mallory in IBM SPSS Statistics 21, Step-by-Step Guide 13 edition, and it's from Pearson Publishing and Darren George, Canadian University College, Paul Mallory, La Sierra University. Okay, so we're going to start on in-screen. We open Analyze. In SPSS, we open Analyze, Regression, Linear, and we're now at the next step. The screen appears at this point is identical to the dialog box shown in the previous chapter. I'm producing it here for the sake of visual reference and show the new list of variables in Help 1 save file. Okay, so we have opened up SPSS. We've opened up the album sales from Fields, and we are right now going to run Fields has already entered the album sales, which is our dependent variable, and our predictors are advertising budget, number of plays on the radio, attractiveness of the band, and then we have the analysis weight. So we are going to run. So in conducting the Fields sales data on bootstrap analysis for the analyze the regression linear, we come out with the model summary showing R at 0.815, but more importantly, the R square, which gives those predictors, those three predictors, gives us about a 67% probability of sales on R square. So in looking at the standard coefficient beta, we see that the advertising budget in thousands of pounds, which is dollar values or the equivalent, and then number of plays on the radio as being significant, both of them right around 0.5, 0.511 and 0.512, which is far more significant than the attractiveness of the band itself. So Field says to click on number of plays and attractiveness, both on control command, and then drag them into independent variables to conduct the next analysis. Okay, so the next thing that we've done is we've gone to statistics in the main bar as described in the book, and they recommend that we click estimates, confidence interval, levels at 95%. In fact, all of the models except the covariance matrix. The only other adjustments that we made was the outliers would be go from 3 to 2 standard deviations. Okay, so now that we've entered as requested, we're going to prepare to run plots on all the aforementioned statistics. Okay, so Fields talks about on page 330 of going installing Z-resid on Y-axis and Z-pred on X-axis. Okay, so we're back again, and we have entered the Z-resid and the Z-pred, but Also, he's going to show us the histogram, the normal probability plot, and he wants to, Fields is telling us to produce all the partial plots, which we will do, and we will do continue. So the short version is that if we look at the 0.085 of coefficient for every 1 unit, that it's the effective sales per thousand change significantly. Right here we have the most important part of the regression, which is the effect that the dependent variable has by adding an additional independent variable to the two independent variables that we had before. So the essence of multiple regression is taking a dependent variable and multiple independent variables and crossing them or applying them to see what the variance is between not only the independent variable and the variable, but the independent variables themselves and their correlation. And that's what's reflected in the table that we have before us, and is also stated in the bootstrap coefficient, although not to the level that the coefficient schedule is stated. That concludes this assignment for multiple regressions on 3.2.16.